Every developer has asked, is this code good enough to ship? But what does good enough really mean today? I think today it's more urgent than ever to answer this question. As more and more code gets written by AI, productivity increases, and we need to maintain and even increase code quality. And I want to answer these key questions. What is code quality? Why it's hard? Why it costs? And how to measure and improve it. Okay, so what is code quality? Let me define code quality in practical terms. For me, code quality is all about reliability. Fewer bugs and regressions. Code that works as intended, aligned with the requirements, works well and doesn't fail at all the edge cases. It needs to be maintainable, easy to understand, to extend, to refactor. It needs to be performant and scalable. It needs to be aligned with the security and compliance practices of the specific organization and the specific team that the developer is on. So unlike more old school definitions that are more focused on the syntax and or very specific testing methodologies, I think in today's realities, with distributed systems, with scale, with a lot of AI generated code, we need to rethink code quality. We need to think how we can make this process scale. How can we set a set of rules and practices and enforce them over time and make this process scalable for large complex code bases like enterprises have. So what are the challenges in maintaining code quality, or why is it so difficult to maintain code quality? Well, it's always a trade-off between velocity and quality. There's rising complexities. There's microservices, cloud-native technologies, multi-language repos, lots of different moving parts. And then you add on top of that AI-generated code. The speed boost introduces new risks like insecure patterns, sometimes missing tests, duplicated code. You have distributed teams that have inconsistent standards and different review practices. And then you have this ever happening organizational pressure to ship it now, ship it fast, fix it later. So this is a very, very challenging setting. So what happens if you don't prioritize code quality? Well, if the organization doesn't prioritize code quality, there are costs, both tangible and intangible. The tangible costs are increased bug fixing, firefighting, and tech debt that amounts. There is slower feature development as engineers untangle this messy code. There could be security vulnerabilities and compliance risks. And then there are the intangible costs. There's the morale of the team, onboarding new developers, it becomes a lot harder, and the loss of customer trust when you have these issues and bugs in production. Is it possible to measure code quality? Well, it's very hard, but it is possible. There are traditional metrics like test coverage, cyclomatic complexity, the density of defects. There are also more modern or holistic metrics. You can look at the code review velocity, so essentially how much time code sits idle in PRs. You can look at maintainability index. There's the bus factor, like, how important each team member is. You can detect duplicated code as well. And then there is developer productivity signals. For example, how often code is reverted or the code survival. And then there are limitations. These metrics are signals, they're not absolutes. The real measure is whether team can deliver features safely, quickly, and at scale. So how does AI affect code quality? Well, AI is fundamentally transforming software engineering. It changes the landscape of how we write and evaluate code, and it comes with new realities. First and foremost, it accelerates software development. It can produce very large volumes of code very quickly and result in a big boost to productivity. But that shifts the bottleneck to the code review side, and the risks are high. AI-generated code often lacks context. Maybe it lacks tests. Maybe it introduces insecure or inefficient patterns, and it raises the bar for review. So we'll need new systems in place, new processes to take review to the next level. You can think about it as the last mile problem of software engineering. Basically, AI-generated code can get you 80% or maybe even 90% there. But those last 10% to make sure that it's well tested, well reviewed, aligned with the requirements, aligned with the best practices of the organization and the team is where the challenge really is with AI-generated code. So what should developers and enterprises do about code quality today? So improving code quality isn't about perfection. It's all about creating a culture and a system and a process where good code is essentially the default. It is important to know that code quality should be maintained both on the organizational level and on the individual level, meaning owned by every developer. For developers, it means to treat quality as part of their daily workflow, not an afterthought. You need to embrace automated tools. The obvious ones are linters, static analyzers, but also AI code review tools as part of that process. You need to write tests as you code, not later. And for enterprises, you need to invest in consistent standards across teams. Again, you need to use intelligent AI and code review tools like Qodo to catch issues early and enforce policies at scale. You need to balance the velocity with governance. Don't block developers, but guide them. Improving code quality isn't about perfection. It's about creating a culture and a system where good code is the default way. So code quality defines whether your code base is an asset or a liability. I invite everyone to reflect on their own practices and then also look at the tools and the resources that are available to help with this process as you embrace AI to scale your software engineering. At Qodo, we believe that great software starts with great code quality because quality is what scales.